Hello. Hello, 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 hello. We're live. I am still brushing my hair a little bit, but before you join, but welcome to the live. We're live. I did my swimming. We are here. We're going to be doing physics and cats. Thank you so much for being here. Welcome to the live. I'm going to share it before I forget. Thank you so much. Welcome Europe. Welcome Asia. Welcome North America. Welcome South America. Welcome Africa. Welcome Antarctica. Welcome Australia, New Zealand. How are you doing? How are you doing? How? So, just did not finish brushing my hair yet. So doing that. How is everybody doing? You're first. Let's rock this mess. Hello. Hello, 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 hello. Thank you so much for being here. Thank you so much for liking. Thank you so much for chatting. My laptop is coming alive as we speak. Thank you indeed. How are you, Doro? Doro says, first, let's rock this mess. Hello, Doro Madness. Thank you so much for being here. And indeed for moderating. Oh my gosh. When people join, they will have to go through Doro. Can't be weird right away. Welcome to the live. Who else is here? Say hi in the chat. Hello, 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 hello. Do feel free to say hi. It'll be popping here soon. I know. Don't tell me. I know. Somebody asked me to wear blue eyeliner today as one of the comments on my shorts. Hello, El Challen. I need to comb my hair too. There you go. I've influenced people to comb their hair. Please do feel free to comb yours. Feel free to brush your hair. You're allowed. You're encouraged. I hope you feel enthused. Cha cha chow, says El Challen. How are you doing, El Challen? How are you? How's your channel going? This is my wet brush. It does well when the hair is wet. It's a very humid day in Boston today. Indeed, it has been raining a lot all day. I did a bunch of chores, you know, kitty litter, trash taking out, cooking. Not too much cooking, but preparing for food, laundry. Then I did the swimming. Then I did my gym swimming thing. Ooh, and I also worked on some other stuff. Earlier in the day, the stock market is very down. Oh my gosh. So yeah, it's been quite a day. And now I'm brushing my hair. It's a little behind schedule here, a little behind schedule. But how is everybody doing? Please do say hi in the chat. Feel free to say something in the chat, and I will read it and I will give you a shout out. El Challen is here. I'll call his buddy Rose in here. JK, JK, JK. Hello, Rose, if you're coming. Hello, everybody. Thank you so much for liking the live. Can we get 20 likes? Could we please get 10 likes and then 20 likes? That would be amazing. Quite amazing. Quite amazing indeed. All right. Actually, Rose isn't coming. That dude is playing a game. Oh no. Oh no. Grimmy. Grimmy is all about the fun and games nowadays. I see. Well, we're going to read about stars and the heavier elements today from Stephen Hawking's book, A Brief History of Time. Past the gas is saying it's been too humid here in Georgia. Hello, Georgia. Welcome. Welcome, Georgia. Welcome, America. Welcome, everybody. Thank you so much past the the gas. Doris says you have one heck of a name. We need 20 likes. Hopefully I pinned the right message there. Oh wow, one of the kitty cats is turning on the shredder. I guess they want to get rid of something, maybe some evidence that they're hiding. Belgium pride. That's true. Belgium pride. That's true. I do have Belgium pride. So, okay, we're gonna do stars. So we were talking about the origin of the universe and the fate of the universe. We're sort of at the origin of the universe part of the book, of the chapter. So not quite this chapter. This is from A Brief History of Time by Stephen Hawking. It's not quite from it. We haven't quite gone to the fate of the universe part of this chapter, but pretty much we were talking about the Big Bang and how things kind of got started, and many million years later the first galaxies were sort of forming and things like that. So over there we will talk about the birth of stars and basically stars doing things and making the heavier elements, because as we know, the Big Bang made, or shortly after the Big Bang, we basically had hydrogen and helium and trace amounts of lithium. So that's what we're dealing with. Hello, Rose. Is this Rose or is this Grimmy? Or is this Rose a different Rose than the Rose that we generally see? Rose, are you Grimmy? What's your ethnicity? I guess the other Rose knows my ethnicity. This isn't our normal. Okay. Well, welcome to the live, Rose. Welcome to the live, everybody. Oh, let me share it real quick. Hold on. So we're going to talk about stars, the first stars, hopefully, and how we got all of the heavier elements, pretty much everything above helium, really, in stars. So that's where we're at in the part of the book. Okay. Let me see if I can use this broken phone to send the live to my channel. I'm gonna share the live to my secretary again. She's getting annoyed when I send them. Why is it annoying to send her the live? Is she not a supporter? Let's see, is my volume down? I think so. Okay. She's a supporter of madness. We only have 3 likes. That's about it. Okay. Can we get 20 likes? And thank you so much. If you see this as a video upload, thank you so much. Looking forward to your likes, comments, shares, subscribes, and all of that. Thank you so much. Okay, I'm going to share it. All right. Where's the button where we share it? There. The button doesn't click. Oh, whoops. Mexi Ghost Hunter 86 says, hello, my dear. Hello, Mexi Ghost Hunter. Have you been here before? Oh my gosh. What is this? It's not working. Hi, Michael Gaming. Fuji. No Fuji. Hi, Mexi Ghost Hunter. Thank you for liking the live. Rose Dawson says just here to leave a like and call out. Thank you for liking. Thank you so much. Have a good stream. Thank you. I've seen you a bit and your interesting lifestyle. Hello, Michael Gaming. Hello, Mexi Ghost Hunter. Hello, Rose Dawson. Hello, Doro. Hello, everybody. I'm trying to share the live. I'm sorry. Give me 1 second. We'll start the reading in just a second here. You say I am. You say I am. Say Nepal. You're from Nepal. Welcome to Nepal. Michael Gaming. Mexi Ghost Hunter. What do you mean by interesting lifestyle? She's so depressed when I don't come. Oh, here's the button. Create post. I'm gonna say we are. I think I got coconut oil on this phone is why it was difficult to click on things. From my coconut oiling day. Batman is here. I'm from the Wu-Tang clan. Hi, Dora. Not the Wu-Tang. Thank you so much for being here, and can you please like the live? Thank you. Maxi Ghost, thank you so much. Please do say more. Michael Gaming. Hello, Nepal. We're all Nepal? What do you mean? Okay. All right. You say today is live and I'm fast and looking and there is not live and I'm going. Look like you're lying. Sorry that I was not live in the afternoon, if that's what you mean. Okay, so let's talk about let's talk about the heavier elements today, shall we? So, as you know, let me back up a little bit. We were talking about the Big Bang. We kind of talked about the Big Bang and the few seconds after the Big Bang, and then it's kind of like cut to millions of years later. Doro, I wonder what you look like. Felipe, hello. Hello, how are you? Some skinny 6'3". We're blood brothers. Okay. There are some blood brothers in the chat, and Doro is saying love you too to Felipe. Okay. Okay. All right. I'll let you guys catch up, and I'll do this. So as time went on, the hydrogen and helium gas in the galaxies would break up into smaller clouds that would collapse under their own gravity. So this is sort of where we're starting to get towards stars and the concept of stars in the universe. As these contracted and the atoms within them collided with one another, the temperature of the gas would increase until eventually it became hot enough to start nuclear fusion reactions. She got stuck again? Do you mean the video is stuck? What do you mean? Thank you for the emojis, Michael Gaming. What do you mean? Is something not working? These would convert the hydrogen into more helium, and the heat given off would raise the pressure and so stop the clouds from contracting any further. So basically, we're describing stars at this point and the nuclear fusion within stars and how that kind of keeps the stars from collapsing under their own gravitation. They would remain stable in this state for a long time as stars like our sun burning hydrogen into helium and radiating the resulting energy as heat and light. More massive stars would need to be hotter to balance their stronger gravitational attraction, making the nuclear fusion reactions proceed so much more rapidly that they would use up their hydrogen in as little as 100 million years. So this is sort of reminding us that the more massive stars actually have shorter life cycles, shorter lifetimes, because they have to burn a lot more energy in order to kind of stay alive, stay burning, and not collapse under their own gravitation, which means they also go through their nuclear power more rapidly, meaning that more massive stars will have more spectacular and more rapid deaths, as in their lifetimes will be shorter. Tomorrow, the oh, I see. Somebody got stuck again in the toilet. I see. Um, I see you walking down streets and seem joyful and positive. Your positivity uplifts me. Oh, thank you, Maxi Ghost Hunter. Thank you for the very nice comment. I do hope that the positivity uplifts you. Thank you so much. It was a very sunny, nice day. It was a good day to walk down the street. I'm the country of Nepal. Whose city? I'm Sukhanagar. I'm in Boston in North America. Welcome to Nepal. Thank you for being here. Tomorrow, first live, stock live. Hello, Ace Wolf. Thank you, Michael Gaming. You're the real star, Andrew B. Thank you so much. Beantown. Yes, back to Beantown. Just give us your full address since you can. I work for a major environmental company based from Boston. Where were you? I went to North Carolina. I know, thank you for clarifying that it's a joke. Otherwise, I was about to tell you my address. Okay, so in 100 million years or so, the bigger stars will collapse, as in they will rapidly die. But where? Wilmington, North Carolina. So in 100 million years or so, they burn up the hydrogen, these more massive stars. They would then contract slightly, and as they heated up further, would start to convert helium into heavier elements like carbon or oxygen. Will give us literally every detail of her address. Oh, shut up. What was the Delio? Delio meaning? What is that? Wakes up telling her... Government contracts. Delio? I wasn't there for work. Just family and fun and all that. Government contracts. Oh, yeah. There were some military planes flying over me. That's true. Maybe there was work. I don't know. Maybe. She was there to give the other people her address. Okay. I want to finish reading this section, but keep your comments coming. I'm just making sure you didn't sell any secrets. To whom? Thank you. Oh my God. Okay. So this, however, would not release much more energy, as in the helium going to... You think this girl can keep a secret? Anyone? Obviously. Okay. They would then contract slightly, and as they heated up further, would start to convert helium into heavier elements like carbon or oxygen. This, however, would not release much more energy, so a crisis would occur, as was described in the chapter on black holes, which is where, a star would kind of die and run out of nuclear power, and during the death, there is probably some massive explosion, and it may collapse down to the compression level of a black hole. Thank you. Los Angeles is freezing cold and windy. Oh my gosh. Well, Boston is very warm today. It's very humid and hot. Hot as in it's in the 60s. Varun says, hey. Hi, Varun. How are you doing today? Like the live stream. Thank you, America, for your liberation days. Indeed, thank you. Helium reproduction is the next billion-dollar industry. Not good? You're not good, you mean? Or what? Not good. What's not good? The economy, yeah. Yeah, I know. So, hi, Faze. Oh, yeah. It should be called Economic Handcuff Day for Americans. What's not good? The economy. I do want an economic chat going, actually. Doro, Trump is not good. Trump rocks. For the whole world, he's wrecking it. Dichotomy. Okay, well, Doro, can you say your points about how once a conman, always a conman, says Varun. What is your response, Doro? um, Doro, have you noticed anything about the stock market? What are your comments? He's gonna make the market fall, make his rich buddies buy assets for cheap. Then he'll take a U-turn promptly. Are you kidding me? He's not gonna. The stock market is already very down. His rhetoric, true. That's true. Varun, he could say something positive tomorrow and make the stock markets better again. Hi, Dark Gloom. How are you doing? Where's Baji and Suji? They're also checking the stock market right now. Everybody, we're all shocked by it. Baji's over here. I'll show you in just a second. My 401k is in the trash. I mean... Okay, so let's talk about carbon and oxygen real quick in stars. So even if you started to heat up more, like helium and whatnot, and make heavier elements like carbon and oxygen, This, however, would not release much more energy, so a crisis would occur as we have described, as in there could be black holes. What happens next is not completely clear, but it seems likely that the central regions of the star would collapse to a very dense state, such as a neutron star or black hole. The outer regions of the star may sometimes get blown off in a tremendous explosion called a supernova, which would outshine all the other stars in its galaxy. Some of the heavier elements produced near the end of the star's life would be flung back into the gas in the galaxy and would provide some of the raw material for the next generation of stars. Our own sun contains about 2% of these heavier elements because it is a second or third generation star, formed some 5,000 million years ago out of a cloud of rotating gas containing the debris of earlier supernovas. So remember, we all come from a sort of metal enriched gas cloud that condensated to make our solar system. So, meaning that our sun and the planets in our solar system were made out of the debris from earlier supernovas or earlier stars that died. Did everybody leave? Can we get 20 likes? Okay, most of the gas in that cloud went to form the sun or got blown away, but a small amount of the heavier elements collected together to form the bodies that now orbit the sun as planets like the Earth. So most of the gas in that cloud went to form the sun or got blown away, but a small amount of the heavier elements collected together to form the bodies that now orbit the sun as planets like the Earth. And we talked about how most of the angular momentum of the gas cloud went into the planets, and most of the mass went to the sun. It's a very interesting formation of the solar system here. The Earth was initially very hot and without an atmosphere. In the course of time, it cooled and acquired an atmosphere from the emission of gases from the rocks. This early atmosphere was not one in which we could have survived. It contained no oxygen, but a lot of other gases that are poisonous to us, kind of like Venus, if you remember, such as hydrogen sulfide, the gas that gives rotten eggs their smell. There are, however, other primitive forms of life that can flourish under such conditions. It is thought that they are developed in the oceans, possibly as a result of chance combinations of atoms into large structures called macromolecules, which were capable of assembling other atoms in the ocean into similar structures. They would thus have reproduced themselves and multiplied. In some cases, there would be errors in the reproduction. Mostly these errors would have been such that the new macromolecule could not reproduce itself and eventually would have been destroyed. However, a few of the errors would have produced new macromolecules that were even better at reproducing themselves. Chickpea, hello. Hi, Chickpea. However, a few of the errors would have reproduced new macromolecules that were even better at reproducing themselves. They would have therefore had an advantage and would have tended to replace the original macromolecules. In this way, a process of evolution was started that led to the development of more and more complicated self-reproducing organisms. The first primitive forms of life consumed various materials, including hydrogen sulfide, and released oxygen. This gradually changed the atmosphere to the composition that it has today and allowed the development of higher forms of life such as fish, reptiles, mammals, and ultimately the human race. Also remember that the ocean helps a lot in the sense that the ocean, that is liquid water, actually takes carbon dioxide and changes it to limestone. So we literally take carbon dioxide out of the atmosphere and convert it to rock. So that also helped to clean up our atmosphere a lot. And then plant life also utilizes carbon dioxide and creates oxygen, which is something that we also obviously breathe and helps out our atmosphere. This gradually changed the atmosphere to the composition that it has today and allowed the development of higher forms of life, such as fish, reptiles, mammals, and ultimately the human race. This picture of a universe that started off very hot and cooled as it expanded is in agreement with all the observational evidence that we have today. Nevertheless, it leaves a number of important questions unanswered. Limestone for cement. I'm the kid in the back of the class. Thank you. Yes, can we get 20 likes? What kind of channel is this, may I add? Sorry I missed that question, Dark Gloom. This is a Cats Plus Physics channel. Maybe I should be more clear in my description. I think I say something like that in the description though. Let's see, somebody else. Baji can pick better stocks than half of Wall Street. Dora, why are you saying that it's a baking channel? You're not helping. Wonderful, says Dark Gloom. To the physics that's going on or to the baking? So, thank you for the question. Okay. What is happening? Thank you. Hi, Faze. I'm not broke, I just don't have any payment methods. What do you mean? You mean there are no payment methods on YouTube? I got you. I think PayPal is something on YouTube. I actually, okay. What was that noise? It got very quiet here. It's actually Fuji? It's actually a microwave channel. Don't talk politics, things get weird. Oh, hi Sachi Mama. Oh my gosh. Okay, let me finish this part. So, it leaves a number of important questions unanswered. Hello Sachi Mama. Why was the early universe so hot? Why is the universe so uniform on a large scale? Why does it look the same at all points of space and in all directions? In particular, why is the temperature of the microwave background radiation so nearly the same when we look in different directions? It is a bit like asking a number of students an exam question. If they all give exactly the same answer, you can be pretty sure they have communicated with each other. Yet, in the model described above, there would not have been time since the Big Bang for light to get from one distant region to another, even though the regions were close together in the early universe. According to the theory of relativity, if light cannot get from one region to another, no other information can. So there would be no way in which different regions in the early universe could have come to have the same temperature as each other, unless for some unexplained reason they happen to start out with the same temperature. Yeah, that is actually that is a good point, isn't it? There would be no way in which different regions in the early universe could have come to have the same temperature as each other, unless for some unexplained reason they happen to start out with the same temperature. So the fact that we have the same temperature everywhere is a good question. Why did the universe start out with so nearly the critical rate of expansion that separates models that recollapse from those that go on expanding forever? That even now, 10,000 million years later, it is still expanding at nearly the critical rate. Hello, Professor. Professor Nick, you can get a shout out. Could you please like the live? If the rate of expansion 1 second after the Big Bang had been smaller by even 1 part in 100,000 million, the universe would have recollapsed before it ever reached its present size. Despite the fact that the universe is so uniform and homogeneous on a large scale, it contains local irregularities, such as stars and galaxies. These are thought to have developed from small differences in the density of the early universe from one region to another. What was the origin of these density fluctuations? So that's a very good question as well. And then rate of expansion being the one that supports expansion versus a recollapse. The critical rate is that's also very thunderstriking. Hello, Harper. How are you doing? Hopefully you're doing better today. Thank you for liking the live. Thank gosh, we got 10 likes. Can we get 20 likes? So, some very good questions indeed. Let's see. Hi, Chickpea. How are you doing today? Hi, FaZe. Hello, Professor Nick. Harper is here. Me and my teacher are binary stars. Aww. Thank you. Okay, let me have some water and then we'll talk about the rest. It is quiet today. Indeed it is quiet. How are you guys doing? Okay, what are you up to today, Chickpea break? Hi, Sachi Mama. Hi. 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 Oh no. Oh no. Oh no. Oh no. Ah! I'm sorry, Sachi. She's still here, but she doesn't want to be held. She does let me hold her. What do you mean? Just not right here. Sachi! Sachi! Oh, oh, oh. It's true. Hello, toy pups. Lover toy pups. I'm about to go to sleep. Hi, beautiful. Thank you. Pretty good. Baji's over here. Baji, do you want to be on the live? I'm trying to move the bar stool here. Here's Baji. He's much more. He is much more. There's only mods here. Here's Baji. Harper is back. Baji Baba, say hi. Baji says hi to toy pups and everybody. I know, Baji is docile. Baji is made for the domestication. He's an American cat. तुम्ही American short hair. He's an American short hair. Bonjour, 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 bonjour. He's an American short hair. Oh, you bubbly, bubbly, bubbly. He has, look at his tiger stripes. He has tiger stripe belly. Tiger stripe belly. Oh yeah, here you go. Harper, Baji will fix your anxiety. He's a very soothing baby. He's beautiful, yeah. He is. He has so many stripes. He has so many stripes. Baji, say hi. Hi, Bulbul. He likes to talk. Sometimes he talks. Baji, say hi. Yes, Baji said hi. Baji said hi. Baji lets me do tummy. Tummy. He does little tummy. Okay, that was Baji. Sachi, ready to be hugged again? Sachi doesn't let me. Oh, but she's right here. She likes to be nearby and to get the company and everything. She's rubbing. Actually, she likes to have total control. She's constantly rubbing against me. Oh, thank you. Thank you, lover toy pups. Baji is very docile, yeah. Toy pups is here. I see. Can we get 20 likes? I see the same person getting timed out by like 2 of my mods. Thank you, guys. Thank you, everybody. All right. Let's read a little bit more. The general theory of relativity on its own cannot explain these features or answer these questions because of its prediction that the universe started off with infinite density at the Big Bang singularity. At the singularity, general relativity and all other physical laws would break down. So we have been kind of talking about singularities in general, and here's one, the Big Bang. At the singularity, general relativity and all other physical laws would break down. One couldn't predict what would come out of the singularity. As explained before, this means that one might as well cut the Big Bang and any events before it out of the theory because they can have no effect on what we observe. Space time would have a boundary, and that's at the beginning of the Big Bang. Hi, Stephen. Science seems to have uncovered a set of laws that, within the limits set by the uncertainty principle, tell us how the universe will develop with time if we know its state at any one time. These laws may have originally been decreed by God, but it appears that he has since left the universe to evolve according to them and does not now intervene in it. But how did he choose the initial state or configuration of the universe? What were the boundary conditions at the beginning of time? One possible answer is to say that God chose the initial configuration of the universe for reasons that we cannot hope to understand. This would certainly have been within the power of an omnipotent being, but if he had started it off in such an incomprehensible way, why did he choose to let it evolve according to laws that we could understand? Yeah. Um, this would certainly have been within the power of an omnipotent being, but if he had started it off in such an incomprehensible way, why did he choose to let it evolve according to laws that we could understand? The ocean is kind of like space, would you agree or not? Yeah. Yeah, it really is. The ocean is very complicated. So, in that sense, yeah. So, the whole history of science has been the gradual realization that events do not happen in an arbitrary manner, but that they reflect a certain underlying order, which may or may not be divinely inspired. It would only be natural to suppose that this order should okay. It would be only natural to suppose that this order should apply not only to the laws but also to the conditions at the boundary of space time that specify the initial state of the universe. There may be a large number of models of the universe with different initial conditions that all obey the laws. There ought to be some principle that picks out one initial state and hence one model to represent our universe. One such possibility is what we call chaotic boundary conditions. These implicitly assume either that the universe is spatially infinite or that there are infinitely many universes. Um, can we get 20 likes? Under chaotic boundary conditions, the probability of finding any particular region of space in any given configuration just after the Big Bang is the same in some sense as the probability of finding it in any other configuration. The initial state of the universe is chosen purely randomly. This would mean that the early universe would have probably been very chaotic and irregular because there are many more chaotic and disordered configurations for the universe than there are smooth and ordered ones. If each configuration is equally probable, it is likely that the universe started out in a chaotic and disordered state simply because there are so many more of them. Which chat? What am I missing? Mm, now I'm curious. What horrid thing did the person say? Is it the thing? Oh my god. How many times are you guys timing out the same guy? Honestly, the timeout drama that happens in this chat is a content of its own. Would you say the ocean, earth, and space are different dimensions? Liked already. Thank you. Ah! I did not, in fact, like it. Good night, my dear friend. Nice to see you again today. Thank you. Maxi Ghost, did you like the live? Oh, God, my arms are sore from the gym. I don't know what is happening. Did the person I saw the initial chat, was that it? Yes, always happy to see you. You never answered. Would you say that ocean, earth, and space are different dimensions? Well, we experience the four space-time dimensions. If you're asking about the hidden dimensions of string theory, which may or may not apply to space and time and all of the physical realities, we will learn more about it from the other book that we've been reading. Well, then I would imagine that those extra dimensions also apply to the ocean, earth, and space. So I don't think that they are different dimensions, but I think my question would be more if there are hidden dimensions that we as people don't really experience, but reality has them. But we understand and explain things in terms of the four space-time, where three spatial dimensions and one time dimension. You know what I mean? So my question is more to do with along the lines of like superstring theory. I don't think the ocean, space, and earth are like different dimensions. Although, yeah, I would say like if you're at the surface of the ocean and care only about the surface of the ocean, then you might regard it as sort of 2DE. But if you care about the depth, if you care about what's in the ocean, then you would care very much about the third dimension. If you care about time, how things change over time, then you care very much about the time dimension with ocean. Same thing goes for the earth. Same thing goes for space. So in this manner, these three things that you mentioned are really nothing different. If you need four space-time, at least, to explain something, then you know that's all there is to it. It's part of the physical reality that we know and love. A piece of paper that's not changing much over time may be described with just two spatial dimensions. But as soon as you care about depth, as soon as you care about another spatial dimension, and if you care about things changing as a function of time, then yes, you would care about four space-time dimensions. But question is whether there are more dimensions, maybe sort of like small ones that we don't experience in our day-to-day life. But when those are accounted for, could maybe explain things like what they do in string theory. Hope that helps. Oh my gosh, did I get a super chat? Oh my goodness. Thank you, Mexi Ghost Hunter 86. Thank you for the $3. Thank you so much. Wow. Oh my goodness, how do I like this? Oh, I can't like it. Um, I was playing Rumi Cube. Thank you, Mexi Ghost. Do fish know we're here? Ah, I see the question. You're asking about fish knowing about us. Whoa, super chat. Thanks, Mexi Ghost Hunter. Ooh, thank you, Steven, for saying thank you to Mexi Ghost Hunter. Very welcome. Thank you, Mexi Ghost. Oh my gosh. Oh, it says bye-bye. Oh, I'm reading it now. Sorry. I thought I could like click on it and I can like it, but sometimes I can like it. Maybe that's a different type of thing. But yeah, I can see the bye-bye. Thank you. Thank you indeed. I actually do have to run. So thank you so much. Thank you, thank you. Do fish know we are here? Let me just make sure. Oh God. Hello, Grimme. Very welcome, says Mexigos. Mexigos, thank you so much for being here. Good night, sleep tight, and I will see you tomorrow. We will continue the chat. Thank you for the super chat. I almost didn't see it at first, but thank you. It's like we're living in the ocean and space is like Earth. Oh. But I have to charge it back. What does that even mean? Thank you. So, if the fish don't know we're here, aren't we in a different dimension? So you have to think about whether the fish experience 3 spatial dimensions and 4, the 4th time dimension or not. Thank you. Hello, Combat Sports. Hello, Combat Sports. Yes, enough time to say goodnight. Thank you, Combat Sports. Thank you, thank you. So we will continue this tomorrow. Phase, I believe Phase is the one who is asking about this. But you have to think about whether if the fish, actually, tomorrow we will start the chat with this fish question. It's an important question to consider. The fish, if they sort of mostly utilize 2 dimensions and don't really experience the 3rd spatial dimension, then you could consider the fish being kind of 2D. And actually, this is a good analogy that we use to understand whether we experience less dimensions than there actually are. Because the truth is, like, say if fish are sort of going back and forth, going back and forth or left and right, whatever, utilizing mostly just 2 dimensions, and they don't care too much about, say, the depth at which they are. I mean, a lot of fish do care about depth, actually, such as whales. They come up for air. They sink at other times. In fact, when they want to die, they sink to the bottom of the ocean, is what I've heard, so that they don't come up for air and they just die. So they do care about depth a lot. But if there are fish who don't care about the depth and they just utilize 2 dimensions in the ocean, then they are experiencing 2D. But they're probably experiencing time. So in that sense, they're experiencing 3D. 2 spatial and 1 time dimension. So depending on which fish, they might be experiencing 2 spatial dimensions and 1 time dimension. So they don't have to know about us in order to experience multiple dimensions. 10 spatial and 1 time in superstring. Yeah, so basically, it's a good point though. Tomorrow we will start with the fish, because it's a very good point to think about how, just like the fish example, does not experience, there could be fish that don't experience a third spatial dimension. So they just experience 2D and time. Same thing, maybe we don't experience certain dimensions which could exist, for example, in superstring theory. Thank you so much. I have to wrap this up tonight, but thank you so much and see you tomorrow. Good night. Bye bye. Good night. 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 Good night.